And this lends itself to a math analysis. If this happened to be a piece of tubular steel, the math people can give you analysis of how much weight this can support. So if you wanted this to be holding up a bridge element or a bridge deck, then this piece of steel can hold up that bridge deck. And these bridges exist in the zone of this size to the zone of this size. There's a little human being. And this steel goes from 4 to 6 inches up to 10 to 12 inches to 2 feet. And they took the tubing based triangle shaped truss supported structures and took them out of the bridge banking business, because you can get as much strength in a piece of just tubular steel, bend that, and you don't have to have all of this. So, one of the things that happens when you make your weight-bearing elements with tubular steel is that you continue to keep coming back mathematically to the shapes that look like this. And it has to do with the nature of the steel. And if we're trying to have shallower shapes, let's put our riverbank in here. And we'll put the water in the river down in through here. If you just want to use the induction heated tubular steel supports, if you go and work with the engineers, they'll get you your foundations here. And then the tubular steel, just pure tubular steel structure that they're going to want to create for you is going to have this kind of a shape to it. If we are working to have this kind of a shape, the flatter this curve gets, the less happy they're going to be about using a tubular steel structure, because the tubular steel structure begins to lose its rigidity for deformation from vertical stress as your curve gets more shallow. And they're going to start saying, we don't want to do that. But what we have the intuition of is that the triangular based tubular steel truss based structural member has plenty of rigidity in the completely horizontal form of construction. These are frequently used all over the world to supply strength of support for a completely straight structure. So there's plenty of construction types who, if they just simply wanted a bridge that goes across here and they wanted it to be flat, they could put a flat bridge across here by making one of these triangular truss supported structures, and that has enough rigidity in it to be a bridge support element without having to have the curve in it. And that just has to be, that's just the way it is. All right. And so we are trying to bring out, perhaps in the bridge that we're talking about, consideration of the use of this triangle base truss braced structural element that lets us have either no curve or a very flat curve. And the interesting thing about this is that this structure is, again, it's beautiful to engineers because it works, but it's actually just ugly. And we are considering a way to take that problem and solve it is to take this triple triangular base truss supported or truss stiffened support structure, and we don't have a real good demonstration of stainless steel. We'll make it green. Okay, you could put around this, if you wanted to, a completely different type of steel round structure. If you wanted to. So that if you looked at it from end on, you would have your three supporting tubular structures, and you would have trusses that were going in between these tubular structures to rigidify this. But then if you wanted to, you could add this skin around the outside of this thing of a completely round tubular steel structure. So if this went back this way, to the human beings who are looking at this structure, they would not see the tubular elements that are inside of it. And so the only thing that they would see as they were looking at it is the green, or the green color. I mean, we're actually going to make the suggestion that this material should be stainless steel. And what you can do, if this is a construction technique, is you can have and we'll pick a color that is more seems to look like stainless steel. You can have a tubular structural bridge element that looks like stainless steel and has all the qualities, the beauty, and the appeal of stainless steel. But if you looked inside of it, it's got these three little steel truss braced stiffened structural elements in it, and that's what we're going to propose to make the bridge out of. Now that we've looked at the bridge elements in extreme closeness, we're going to want to back away from them a little bit. And again, each time we do this, we have to recreate our little riverbank. And we'll put some water in here. And now we're going to have, and we're picking red because we're going to push for brick, but we have a brick bearing structure on each side of the river. And we're thinking to put a walking deck. We are going to make the argument that the walking deck should be flat. And so beneath it, we've chosen our shiny blue as being the curve element that we want to put in the bridge to support this walking deck. There's our curve element. And the specific and exact effect that we're trying to get here is a form of construction where this distance is kept as a small distance. This is a small distance here because it makes for a much prettier bridge, even though this distance is long. We are trying to keep this distance short because it's a prettier bridge. And we're going to, as you can see from our blue color, we're going to hope that we can propose this to be a stainless steel tube, but it's not a stainless steel structural steel element. It's only there for looks. Inside of this stainless steel tube is the 3-tube truss stiffen support structure that we've talked about. And of course you may be saying, how are you going to get these bent structures bent with these parts inside of them? And one way to do this is to build your 3-tube truss stiffened structure and take it to the inductive heating or inductive heating group and have them bend this for you in their inductive heating oven, and request that they bend it in a particular type of curve that has the shape that you want from an aesthetic viewpoint, so it's pretty. But it happens to be bent in a particular type of curve where once the curve is bent, you could put something in it or put something around it, where they take your stainless steel tubing and they put the stainless steel tubing in the inductive heating machine, and they bend the stainless steel tubing, and they bend the stainless steel tubing in a curve that is an exact match of this curve. And the way you construct this bridge element that you want to have is you take your stainless steel curved tube and you take your 3-element truss supported stiffening tubular structure and you take this, and of course you can see we're going to have to rethink our stainless steel structure. If this is the size of our rigid tubular structure, then